We are starting our oral presentations now. We have here Dr. Anandarup Goswami Garu and Nagarjuna Garu as our judges. I request Nagarjuna Garu to felicitate Anandarup Goswami Garu.
Very warm good afternoon to one and all. My name is Kundana Sai and I am coming from Padmavati Mahila Visvavidyalayam, Tirupati. And I am going to be presenting on the topic aquatic bioremediation, a practical approach with microalgae enabled floating units for heavy metal chelation and for improved dissolved oxygen. I am also a fellow of TST Prayas. I have also got funding for this particular idea to prototyping stage, and I was also one of the 13 selected startups from throughout the country for American Council for Innovative Research at a Nexus Incubator, New Delhi. So today I want to share with you what I am working on this international conference. And I forgot to tell you that I am still in my 7th semester of Integrated Master's Program Biotechnology. So let's start this very casually. We know there is a very big Hindu festival coming in the next week, which is Delegates. And we are all very familiar with the idol present here. And what is this basically made of? Plastic. And what makes these idols very attractive? The colors and the paints. 9 days we worship this Lord. We worship this idol, and then we go and immerse them into water bodies. Post that, we have all these problems. So this triggered me to research on how is our water body getting affected with these mass idle immersions. Wherein I found out that it depleted the oxygen levels, increased the pH, temperature, affected the carbon dioxide levels, as well as introduced lipids and grease. But what's more concerning, because all of these parameters are the basics for any type of water pollution, any foreign contaminant you are introducing, these are the first parameters that get affected. But what is the most concerning part? The heavy metals. Heavy metals are the most crucially polluting component of these idols that are majorly of our concern, that should be of our concern. What are heavy metals? These are heavy density metals or metalloids. This is a broad term, and the components need not be metals or metalloids. For example, arsenic, it's a metalloid. And there are a lot of sources. During my research, or when I was doing my literature review, I understood that this heavy metal pollution was not just limited to idle immersions. It's a whole big problem coming from multiple sources, which included majorly from anthropogenic activities, which also includes idle immersion, and from natural sources like natural disasters, which are contributing but still to a very limited extent compared to our contribution. Then most of our introduction of heavy metals is coming from industries, agricultural activities, and domestic activities. Even the batteries you use contaminate the environment with their heavy metals. Some of the brief examples. Most toxic are lead, zinc, cadmium, chromium 6 to be particular, because that is quite hard to eliminate from any energy. So why should we be concerned about this whole heavy metal scenario? Because according to Central Water Commission, which is a very topmost body that is governing and studying about the water resources of the country, that reported about 79%. That is 3 out of 4 rivers or 4 any sort of water body you take is polluted with heavy metals, which is concerning. Don't you think it is concerning? Yes. And the worst part, it is polluted with 2 toxic heavy metals, not just 1. 2 toxic heavy metals beyond permissible limit. One more statistics, 69 rivers of our India are polluted with lead. We might be very familiar with lead toxicity. The toxic, the not so good effects it has on the whole ecosystem, and if we are very selfish being humans, it also has effects on our human health. And 2 majors with 42 major rivers with heavy metal pollution, which indicates that most of our rivers are severely polluted with heavy metals. So, to brief out, all of the major human physiological conditions are affected. But don't you think we have deficiencies, zinc deficiency, copper deficiency, that says, what should we interpret that as? We need heavy metals, but to a very little amount. They are micronutrients, but beyond that, they interfere with the physiological processes and the whole metabolism, and hence cause even the risk of cancer. What can we do? We all have water purifiers at our home. That's okay. But what about the water bodies as a whole? We are not concerned about the whole ecosystem. So that's why we need to remediate those water bodies, right? We need to clean the heavy metals from the water body without affecting the native ecosystem and the biodiversity in the aquatics. For example, fish. And why should we be concerned about the aquatic ecosystem? Because ultimately we are also dependent, we are all linked in the whole food web. That gets magnified. Toxins get magnified by 10% in the very next level of our food chain. That's why we also need to focus on remediating the whole ecosystem rather than just limiting it, the remediating level at our personal level. And bioremediation is not a new concept. Remediation is not a new concept. We have many types of technologies like capacitive deionization or ionic exchange, ionic precipitation, etc. But what is concerned here, we are dealing with the whole big water body, which means it is a large scale application we need to find, and we need to have a versatile device or a mechanism that is versatile to be suited for any type of pollution. We said 2 toxic metals, but I didn't mention which toxic metals because there are a lot of combinations involved in that. So we need to have these 3 parameters in our mind when we are designing a solution. Minimal invasion, we need not disturb the aquatic ecosystem. For example, chemical precipitations does release secondary pollutants which damage the ecosystem. Scalable, as I said, and versatile. That's when MEFU comes into the picture. What is a MEFU? MEFU is a microalgae enabled floating unit. Floating units are already existing. They are just nets of plants planted in a matrix of soil and coir. They keep floating in water bodies. No control over where the floating body goes, but they accumulate pollutants from the water body, they claim it, but no quantification report on that, howsoever. So this MEFU, from the floating unit, we have taken a part of the floating unit. That is the biont disk that is floating on the top. That's where our whole principle starts to make it scalable. And why did we include microalgae? Because there are these plants called hyperaccumulators which are known for accumulating heavy metals through their roots. Very good. But they are not scalable and we need much more efficiency involved. That's why we use microalgae. Microalgae are tiny plants, or they are very small primitive plant cells, but because they have very increased surface area, they can do their function efficiently compared to plants. They are equal to 100 trees. 1000 liters of algae, or if you take approximately this size of algal tank, liquid algal tank, that is equivalent to nearly 10 trees of oxygen release. That's why liquid trees are becoming famous nowadays. If you go to metropolitan cities, these liquid trees and the startups involving with working on air pollution powered by microalgae are gaining much more recognition nowadays. So how are we implementing it in the water pollution? So this MEFU includes all 4 crucial principles that have already been primitively proven: adsorption, phytoremediation, nanotechnology, and phytoremediation. Phytoremediation is the remediation we use by using plants, whereas phyto means algal. So we use microalgae, hence phytoremediation. Adsorption, I'm going to move on to the next. And we're also using nanotechnology, but I will explain it in the next slide. So in short, it is a device that can make water in polluted water bodies clean by using natural processes. We don't trigger any sort of chemical reactions into the water. That's why natural process. It's a practical and scalable solution for in situ bioremediation. And mainstream chelation process is supported by secondary systems. That's where nanotechnology and the absorption system comes into the picture. So this is a brief description. The whole design of the device is, I've not included that here because I've saved that for my proprietary sake. So the floating body, as I said, is made of bionic material, which includes cocopeat, and these are all plants. So all of these are actually weeds, aquatic weeds, which are very good in dragging the nutrients or organic pollutants and heavy metals and trapping it. And in the center, we have an immobilized algae chamber, microalgae chamber. But in reality, according to the design, why did we include this floating body? We could have done the only microalgae chamber, modified biomass and passive aeration. Why did we include this? Because any sort of in situ bioremediation faces the major problem of filtration. Because the debris gets stuck into the bioreactors. Even if it is costly and the government decides to invest on such a thing, the filters get clogged. That's why we have used plants and the floating biome system here. The fibrous roots over here trap the debris and pass the partially filtered or secondary filtered water into the immobilized microalgae chamber, which is a long transparent chamber. So we are not using, and optimally microalgae requires 6 hours of light time and 6 hours of, sorry for that, 12 hours of light and 12 hours of dark period for their multiplication. Just like normal, it's suitable for the normal condition. That's why we made it transparent and long. So the microalgae are receiving secondary treated water, eliminating the probability of secondary contamination happening and the introduction of physical debris. In the microalgae chamber, the microalgae are known for this heavy metal because they have their cell walls made up of special components like some specific glycoproteins that are known for chelating heavy metals. They take up and trap the heavy metals onto their cell surface and also convert them into non-toxic forms like carbonates. Okay, that specific mechanism is called bioprecipitation. So after chelation, that moves on to the next chamber, modified biomass. This is where the absorption process comes into the picture. So the modified biomass is just agricultural waste that we find and don't have any secondary value, that we didn't find any secondary application yet. So we are going to modify that into some other product, or we are going to transfer that or make it modified functionally by adding functional chelating agents like EDTA, citric acid, phytolone, whatever is suitable for that particular situation. And the biomass selected is majorly from the sources that are not being used for the second time. For example, rice husk. Most of the silica-rich materials, all of that are sent for composting, or some of it is just burnt in the fields. We are going to procure that biomass and modify it and include it in the second chamber. Then that water coming from the microalgal chamber to the modified biomass chamber gets passed on to the passive aeration system, where we use aeration system called Venturi flow meter, which doesn't use any electricity to increase the dissolved oxygen. Oxygen gets increased crucially in the microalgal chamber itself, but this increases it to the next level. And why did we use the term immobilized microalgae? Rather than free microalgae, immobilized microalgae. We are just going to trap that microalgae into small beads having a matrix. This is where nanotechnology comes into the picture. We have designed a matrix that has a few nanotechnology components like nanocellulose and some other components like magnetite and other nanoparticles. So this is going to increase the efficiency of microalgae, further enhancing the chelation. So this hybrid mayfood technology, as I like to call it, this is a solution that can be scalable. So this can be planted or introduced in whatever places we want to treat the water. Okay, in a water body, multiple of these mayfoods can be introduced and banked onto the river bank. So Whenever the modified biomass or the microalgae reaches a saturation point, we can retrieve the unit and refill it. Okay? So, with my conclusion, this hybrid technology is anticipated to be a practical, scalable, yet versatile technology for in situ bioremediation for heavy metal contaminated water bodies. And this has multiple advantages over the existing technologies by harnessing natural processes, low risk of secondary pollution, relatively low cost to benefit ratio, and scalable. It's a scalable process. Thank you. And some part of this, so my mentors are Dr. Nandakishore sir and Dr. Shilpa ma'am. So we are collaborating on creating this technology to empower our Indian government in cleaning the water bodies to provide our next generations with clean water bodies and a very good ecosystem, an overall good ecosystem for the future generations. Thank you. And I'm open for questions as well. I take this as a very good platform for constructive feedback. If you have any doubts, please, because all of this work started as something and ended up being something else, but for the sake of good.
So this matrix, you're assuming this to be biocompatible, right?
Yes, sir. It is biocompatible because we designed it with biocompatible materials.
No, that's true. No, now my question is that for all the matrices that they should be having also certain functional groups which may be attracted for the heavy metals, right?
We make sure that the immobilization matrix is also chelating in nature. We do that.
But then it will end up actually having a layer covering your.
Okay. So the question of biofilm formation, is it?
That's a possible, maybe not in the first cycle, but
yes,
over the time that will be a possibility, no? How do have you thought of encountering that one?
As of now, we've not yet entered into the biofilm formation research steps. But what I'm anticipating and what I'm telling you is, because the microalgal chamber has these baits and the water is continuously flowing. And I think that force prevents the biofilm formation. And I have not done any studies on that. I'm just telling you that because the chamber is not completely compactly packed.
Okay.
It still has water flowing inside.
Okay. And that biomass that you said for adsorption, so how normally, so that is actually embedded in your entire system, or is it actually?
These are separate components.
Okay.
These are separate components linked with perforated filters.
Perforated filter. Okay.
Thank you for the patience, and you've been a very good audience. Thank you.
I'm Velagapudi Suhasini, working with Government Degree College Falaknama as an assistant professor. And right now, I got an opportunity to do my research work in GITAM University, Hyderabad, under the supervision of I.V. Subbareddy sir. So because I always interact with the students, so I'm happy to see much students. I hope physical sciences students are present over here. All are from life sciences, or all are life sciences? Okay, no problem. It will be more enthusiastic for you people to learn something new other than from life sciences. So my topic is on fiber optics. Fiber optics, and it is related with completely with the photonics and whatever the gadgets, whatever we are using right now, it is completely immersed, and we are using with that photonics. Okay, so my topic is on lithium niobate. It's a crystal structure. Okay, it's very interesting if you listen like a story. Okay, I will not go by step, or I will not teach you what is a formula or what is because I want to explore, or I want to teach you much on that. Okay, so my topic is on lithium niobate. Okay, that is related to the fiber optics, in which it is a stoichiometric, but my research work is on lithium niobate with a congruent. Okay, so it will be similar with the stoichiometric. Stoichiometric, it is nothing but which we get it in naturally. Okay, so through congruent lithium niobate is nothing but doping. Doping will be done to make that element as a lithium niobate. Okay, so first thing is that I just want to explain you the basics, so then you can understand what I am trying to reach you out. Okay, so then this is on the topic. So from my research work, I have taken some of the interesting topic. What I have done the research through the literature survey. Okay, from past 50 years, the research is keep on going on this lithium niobate. So still it is progressed, and further also it will be continued definitely, because it's a versatile, lithium niobate is in a versatile and extensively used in many applications like photonics, and it's used in optical communications, it can be used in procedures, it can be used in surveillances, wherever, you please name it, wherever, whatever we are using, all the gadgets, whatever we are using, everything that is always involved with this photonics and nonlinear optics. Okay, coming to the topic, that is on study of thermo-optic and thermopolarizability coefficients of congruent lithium niobate. So I am clear, I think, that why I am specifically saying about the congruent lithium niobate, because we made it as an artificial to get a good bandwidth or band energy, whatever we name it. Okay, so when compared with the stoichiometric, congruent will be made with the artificial and can be used with a good bandwidth. Then by using a optical waveguide using point dipole approximation. So going to the next slide. Yeah, this is the abstract. I am not going to read, and I just want to tell you the introduction. In the abstract, whatever different wavelengths I have taken means different lights. That might be different colors of the lights. That can be red, blue, green, yellow, whatever. I have taken red and blue, and with no color also. Different wavelengths means different lights which are propagating on that material, that is lithium niobate material. So when the light propagates on that material, so how the reaction is taking place, means lithium, niobium and oxygens are there. So how that is reacted, how that reaction is helping, and how the output we are getting, I have done that. So through the literature survey, thermo-optic coefficients are done. Till the literature survey, thermo-optic coefficients are nothing but how the thermo is nothing but variations of the temperatures. That can be taken any different temperatures. My temperature starts from 293 to 773 with 3 different wavelengths. Okay, 0.6328 and 1.14 something and one more wavelength. Okay, so 3 different wavelengths with so much of different temperatures I am varying. So in previous literature survey, what they have done, they have taken one single wavelength with the room temperature, they have varied. So I am not deviating completely from their literature survey, and I am not doing something new. I just want to do the research which is varying with the different variables and constants. Okay, going to the next slide, that is about the introduction, and these are the properties which I have discussed right now. So this is the structure of the lithium niobate. This is the structure, and this is how, because of using congruent lithium niobate, how the improvement will be there for the larger electro-optical coefficients, lower electric field, and how the higher efficiency will be there and better for the homogeneity. Okay, so going to the topic, that is about the crystal structure. I just want to tell you how these crystal structures are useful to find the point dipole approximation. When the light is incident on this structure, that is lithium niobate, how it is reacting. So what happens when the light falls on a material, it starts vibrating and it re-radiates. So the re-radiation is happening, means ordinary and extraordinary rays will be coming. Ordinary ray will be flowing normally, but extraordinary ray takes time to flow. Okay, so because of that incident light, each ion gets oscillates. Oscillates means it will be in a wave, and every wave, the natural frequency is nothing but everything, whatever we take it, everything will be wave. Because I am a physics lecturer, So we always talk about a wave continuously because we take any wave, that is sound wave, light wave, everything will be in a wave. It's a God's created, nothing which we have created. We are just finding out, oh, this is also a wave, that is also a wave, water is also a wave, right? So in that way, everything, whatever the light which is falling on a material, that starts oscillating, that gets vibrated and it re-radiates. So in that wave, which is oscillating and vibrating and re-radiating and hitting the another electron. So the electrons gets, all the electrons gets vibrated. So the beauty of the lithium niobate crystal, what happens? All the lithium, niobium and oxygen get started vibrating and re-radiating and transmitting the energy from one electron to the another electron. So how lithium is vibrating or transmitting the energy? Oxygen is vibrating and re-radiating and how it is being transmitted, and how niobium. So I am just finding out how it is vibrating and re-radiating the energy from one on one. So I am just going to find lithium on lithium, niobium on lithium, or lithium on oxygen. So effect on and effect due to. So effect on, effect due to is nothing but I am just going to vary how this is affecting, how we know the atomic numbers of the lithium, niobium and oxygen. So niobium will be 41, oxygen is 8 and lithium is 3. Lithium will be always constant. There will be no much difference because of the researchers or the literature survey, lithium is always constant. There will be no vary. I am not boring, I hope, right? So coming to the concept of the polarizabilities, so the polarization takes place, how the polarization takes place, how this all this lithium, niobium and oxygen is getting vibrated and radiated, and how this light is propagating to the media. Means how much depth, intensity. I am going to find the intensity. Okay, this much of intensity, this much of the temperature, I am able to vary. Okay. So through these polarizabilities, I am able to find these equations which was been already proven. I am not going much depth of the equations, so I don't want you people to get bored. So finding out that equations, what I could find, okay, x-axis, y-axis, z-axis. X-axis how? X and y or z. When a light propagates on x-axis, so all the lithium, niobium, oxygen through the x-axis, how it is varying with the y, how x and y is varying with the z. So what I could find with the x-axis, y-axis and z-axis is nothing but x and y will be near, z will be little far when compared. So the difference between the distance between the niobium or oxygen or whatever I name it, okay, I am able to find the difference between the lithium, niobium and oxygen when it is propagating in that direction, x direction, y direction or z direction. So I can find the each cell or each unit cell how it is propagating the energy. That is what is about the finding. So here I already told you that how this ordinary ray is reflecting, extraordinary ray is reflecting. So ordinary ray will be propagated so simply, but when extraordinary ray, it takes time to get the light or the wave, whichever it is coming out. So I am going to find the birefringence for ordinary and extraordinary. If I am able to find for the the refractive indices, okay, the refractive indices for the light which is propagating, I am able to find easily the birefringence of ordinary and extraordinary. So if extraordinary will be always increasing when compared with the ordinary, so definitely the birefringence will be increased. So here I have taken the values for 3 different wavelengths for finding out the ordinary and extraordinary rays. Here I have given the colors for the black and green and blue for the ordinary, and rest of is extraordinary. Here we can see when compared with ordinary, extraordinary will be increasing more. So that is what I could find out. Next will be the temperature dependent of the birefringence. So finding out with the birefringence is nothing but ordinary and extraordinary. Varying with that, I could find the birefringence as I told you the previous slide. When the extraordinary is increasing, automatically the birefringence range is also being increased with the different wavelengths. So next, coming to the proper topic, that is thermo-optic coefficients versus temperature in lithium niobate with open type optical waveguide for various wavelengths. So I have taken various wavelengths. So thermo-optic coefficients are able to calculate, and we are able to find the different wavelengths with the different temperatures. I am able to vary how the lithium and niobium is, oxygen and niobium is varying, because lithium is constant. Lithium is constant all the time. So I am able to find oxygen is increasing more when compared with the niobium. Why? How? Why it is happening? Because oxygen value is very less when compared with the niobium. Niobium atomic number is 41. It takes time to increase. Oxygen is very small, so it automatically gets increased. So this was done by the thermo-optic coefficients with a one single wavelength and with a room temperature, but I could vary with a different wavelengths and then different temperature, and it is not deviating. Another 5 minutes, please. Over. So here I am able to find the variations of thermopolarizability coefficients of constant. As I told you, I am going to vary with the constant alpha Li, that is alpha is nothing but polarizability of lithium, making it constant and variable. So here I could find the differences with the constant alpha Li and a variable alpha Li. Here I could find with the same wavelengths with the different temperatures, I could vary for which is constant as well as variable. So variable and constant is almost, it is having some deviation, but it is not deviating completely. So it is successful. So my research work which I have done, it is not deviating completely. So this can be utilized for so many other applications. In any applications that is related to the photonics or for the study of the medical purposes, which can be used in the lasers, this is going to be helpful for using in different applications. So this is my research which I could done with the finding out with the literature survey, and I am able to find out a proper output which is not deviating completely. So this is the results when oxygen is increasing, how niobium decreases, when niobium increasing, how oxygen is getting decreased with the thermopolarizability coefficients. This is about my results and discussions. That's it. Thank you. Please. Thanks a lot for your patience. Any questions, please, love to answer. Different wavelengths I am taking, no?
Okay.
So that is only the light. It is a, this electric and magnetic field which is having a longitudinal wave that is propagating. So I have taken different wavelengths, means different lights. So I am finding with that. That is the source. Nothing different or nothing something different from the research I have not done. Sir, it is my research is on theoretical, based on, it's theory, but experimentally also done. Experimentally also done, but my work is on theoretical.
Theory-wise, so how do you actually, when you write lithium, niobium,
Oxygen, yeah.
how do you differentiate that amount of niobium is to oxygen ratio theoretically? But then you said, no?
Yeah, 0.946, sir.
So it's not 1:1.
No, 1:1 is stoichiometric. Stoichiometric. So,
Deliberately remove some of them.
yes, we have made it artificially. Yeah. Thank you, one and all.
Working under the supervision of Dr. Praveen Kumar Reddy Adiyala in the Department of Organic Synthesis and Process Chemistry, CSIR, Indian Institute of Chemical Technology. Today, I want to discuss about light-induced diastereoselective keto-esterification to access 6,5 tetrahydrobenzofurands in batch and continuous flow conditions. Prior to that, I want to give a basic introduction regarding photoredox catalysis. We are well known that all the living organisms depend upon plants for food. Whatever the, not only on for food, but medicinal uses, everything, plants are the major sources for us. Inspired from that, light-induced reactions has been introduced. Light-induced reactions are nothing but the chemical reactions which will be starts by being absorption of the light. However, there is a limitation for that because all the organic compounds cannot absorb the visible light. So So the photocatalyst has been introduced. By use of the photocatalyst, this limitation can be overcome. Photoredox catalysis. Photoredox catalysis is nothing but the light-induced reactions were accelerated by using a photocatalyst. Photocatalyst has a general property where it has two electrons in T2G state, and by the absorption of the light, it will undergo one of the electron will excited to pi star. This pi star electron, whenever in the presence of an acceptor, it will be donated, or in the presence of a donor, it will be accepted by the other electron. Coming to the general mechanism of the photoredox catalysis, primarily there are two possible mechanisms for the photoredox catalysis. That is, one is reductive quenching and other is the oxidative quenching. Coming to the reductive quenching, whenever the excited catalyst will undergo reduction and form reduction, it is called a reductive quenching. Whenever it's go oxidation, it is called oxidative quenching. Next to that, I am coming to my topic, that is light-induced diastereoselective ketoesterification to access 6,5 tetrahydrobenzofuran derivatives in batch and continuous flow conditions. It is published in JOC 2024. My topic is, we herein successfully developed a visible light-induced diastereoselective ketoesterification to access 6,5 tetrahydrobenzofuran in batch and continuous flow conditions. Coming to the highlights of the mechanism, highlights of this methodology, it is a catalyst-free and additive-free reaction. It is an atom economical procedure for ketoesterification. Implementation of continuous flow reaction setup has shortened the reaction time to 2.45 minutes, which is 48 hours in the batch condition. These are some of the important biological active compounds which has the ketoester as its backbone skeleton. These are some of the important compounds in the medicinal field. Previously, the aryl glyoxylic acid has been well utilized for giving the acylation process, but the formation of the ketoester is very limited. Papers are available, and it is one of the most anticipated topic in the present synthetic field. There is one of the report using aryl glyoxylic acids for the ketoesterification in Organic Letters 2018. One more important molecule is the cyclohexadienone. This cyclohexadienone is well reported, and there are multiple publications in the transition metal catalysis to synthesize the 6,5 tetrahydrobenzofuran derivatives, where to 6,6 dihydrochromons using visible light catalysis. However, there is no report has been there for synthesizing of the 6,5 tetrahydrobenzofuran using light. This is our pioneer report in this strategy. There is one report for acetoxylation using palladium catalyst, which is a transition metal catalytic reaction to form 6,5 tetrahydrobenzofuran published in 2023. We herein developed a methodology for ketoesterification and forming a 6,5 tetrahydrobenzofuran ring using blue LED as the light source for 48 hours. In a batch condition, we observed the 6,5 tetrahydrobenzofuran ring by ketoesterified compound. We have optimized the different light sources, different catalysts, and found that there is no catalyst requirement and no additive requirement for this reaction. And we have synthesized multiple substrates of the reaction, and these are some of the substrates for the methodology. After the synthesis of the substrates, we went for knowing the mechanism of the reaction. Further, we have conducted some of the control experiments. As it is a light-induced reaction, we have primarily thought there will be a radical in the mechanism, and conducted the reaction with the radical quenchers like BHT and TEMPO. And the results are failed. That means there is no radical is observed in the mechanism of the reaction. We can know whether the mechanism is mechanism following an atom economical process. We have conducted the reaction with deuterated glyoxylic acid and found that the alpha position with the deuterium atom. This says that the mechanism is involving the atom economical procedure, and the proton which is coming at this alpha position is from the glyoxylic acid. To make sure that the methodology is working in the presence of light, so we have conducted the experiment, that is light on-off experiment. We have conducted the reaction by on the light for 5 hours. For every 5 hours of interval, we have stopped the reaction for 1 more 5 hours. By offing the light. Whenever the reaction is present in the presence of light, the reaction is being proceeded. When the light is absent, there is no reaction was observed. This was monitored using TLC for the results. From the control experiments and previous literature procedures, we have proposed a plausible mechanism for the reaction. Primarily, the glyoxylic acid. The glyoxylic acid, which has a pKa value of 2.15, it will undergo excitation in the presence of blue LEDs, and at the excitation stage, the pKa value will be 0.85. We have confirmed by UV experiments. As the acidity of the compound is very high, the proton will undergo deprotonation will be occurred. This proton will undergo coordination with the ketone of the cyclohexadienone to form the intermediate 2. This intermediate 2 will undergo coordination with the glyoxylate anion to form the intermediate 3 or 4. As there are two possible intermediates, that is 3 and 4. The 3 intermediate is cis, which is sterically favored for the next protocol. So the protonation and the protonation will be occurred, and dearomatization will be taken place to form the desired product. This structure was confirmed by the X-ray crystallography techniques. After the confirmation of the reaction in batch reaction, we have went for the continuous flow setup. For continuous flow setup, we have took the BD syringe and with both the starting materials in our solvent, that is DCE, and passed through the PFA capillary with different flow rates, and found that 80 microliter per minute has given our desired product with good yield in 2.4 minutes. This is a laboratory setup for the reaction. This is a flow pump, and this is a BD syringe, and this is a PFA capillary. The PFA capillary is rolled in this with which can observe the blue LEDs, and this one more end is connected to the RBF, which is in our inert atmosphere, to collect our desired product. In the from the batch protocol, the efficiency of the reaction has been increased, and time of the reaction is decreased to 2.4 minutes. After the confirmation of continuous flow reactions, we went for the gram scale reaction and found that the reaction efficiency is slightly changed in the gram scale reaction, and the product was two products were isolated in the gram scale, and these products were deketoesterified, and keto compound was synthesized for these compounds as a synthetic utility. Coming to the conclusion, we have developed the metal-free ketoesterification approach to synthesize 6,5 tetrahydrobenzofuran derivatives. It is regio and diastereoselective reaction. Continuous flow has enhanced the efficiency of the reaction. It is atom economical and economically friendly reaction, because there is no additives or catalysts in the reaction. It is an economically friendly reaction. We have demonstrated the synthetic utility and gram scale reaction to show the practicality of the reaction. With this, I want to acknowledge my supervisor, director IICT, and head of the department, lab mates and friends, and CSIR IICT, and Icon Bharat for giving such a great opportunity to me. Thank you one and all for this.
But what are the applications of the compound that you have synthesized?
We are well known that the organic synthesis, this is a methodology chemistry. What we have done. For synthesis of the natural products, there are multiple steps must be required. For that, one of the method may be the ketoesterification procedure. You have seeing this molecule. This is a ketoesterification backbone moiety. So to synthesize such.
Maybe I was not clear reaching out to you. I was asking about the product's application. You have made an environmentally friendly reaction. I understood that point. But what are the final applications of your product?
The final applications are under biology team is working with that. All the products were submitted to our biology team. They are working on that.
Is that a novel product?
Yeah, it is a novel product.
After this, we start this. So what is happening?
So the compound is undergoing cleavage, and here there is a ketone ring is getting formed. This formation of the ketone ring from the moieties is one of the important protocol in the chemistry synthesis. This is a gram scale reaction, sir. Actually, the reaction which we kept in the above batch conditions is about milligram level, that is 100 mg 500 to 200 mg level maximum. For whether it will work in the higher quantities, we have conducted the reaction with gram scale with 1 gram of the compound and isolated these two compounds.
But you don't see the next step that you did it deliberately, right? That is not on the batch. I mean, that is.
This is not under continuous flow, sir. It is a batch protocol. To know the utility of this compound, whether this compound can be subjected to further utility, we have demonstrated one of the examples.
Then I'm asking that there are so many aggregates which can be deprotonated in order
Yes.
to give you a structure, right? So it's good that it's fine.
Thank you, sir.
Sridhar Reddy. So first of all, I would like to say thanks to the Icon Bharat for this wonderful opportunity. So today my presentation entitled with CH annulations of unsymmetrical functional alkynes. So some little bit introduction regarding the CH annulations, right? So this is alkyne and a difunctional reagent under transition method catalysis, it gives the heterocyclics. If the alkane is symmetrical, there is no challenges. But if the alkane is unsymmetrical, so the following challenges arises. That is regioselectivity and stereoselectivity and chemoselectivity. So in our strategy, we are using unsymmetrical functionalized alkanes by using provocative alcohols. So the multifacial functions, the presence of hydroxy group, it controls the selectivity controller and reactivity activator and electronic bias through the coordination of the metal with the two pi partners. This is my recent publications was published in ChemCom. That is, so rhodium catalyzed chemo, stereo and regioselective of indole oxypropanetyl to synthesis of pyrenoindole synthesis. So here are some earlier reports which was published in JACS in 2012. Wang and group reported benzoyl acetonitrile with the alkane, that is naphtha-pyrene derivatives. And same group later 2017 they reported carboxyl derivatives. And later with provocative alcohols, Fan and group reported fulvin deoxygenated product under rhodium catalysis. So inspired by these collective studies, we reported that hydroxy ester and indole propyl, that is naphtha-pyrene derivatives. So they are, the advantage of our strategy is that is highly chemoselective and regioselective and stereoselective and heterodeal reactor. So this is some of the biological products. So our optimization studies. So our optimization started with the several screening of studies. So we observed that rhodium Cp star 3 mol% and copper 2 equivalents and cesium carbonate 1 equivalent and THF at 80 degrees is the finest conditions to deliver the product with 73% of yield. And at the same time, we also tested with the different catalysts like ruthenium catalyst and palladium and different bases, cesium carbonate and organic bases, triethylamine and different oxidants. So from the all R, we reported that protocol is the finest conditions to deliver the pyrenoidal derivatives. So this is the substrate scope. After having the optimization conditions, we synthesize the different kind of derivatives irrespective positions of indoles. And later we shifted to the hydroxy side. So it has a broad substrate scope with the different alkane chain and fused rings and naphthalene derivatives. So from that, there is no steric hindrance effect on our current protocol. So the structure of 3AH ascertained by X-ray crystallography. So these are the some control experiment to understand the reaction mechanism. So yeah, we performed at our standard conditions with the diphenyl acetylene. No reaction was observed, and propagyl alcohol PA was recovered. So with the propanyl acetate, some complex mixture is observed. From this data, we observed that the chelation of hydroxy group with the metal is the suitable pi partner for these annulations. So, and by using 2-methyl indolyl propoxyl, there is no C4 annulation of product was observed. So we are also performed some deuterated studies. And by using hydroxy ester with both aromatic and aliphatic, so aliphatic ester is more reacted with the indolyl propylate with more than aliphatic. And at standard conditions with the deuterated solvent, so there is deuteration happens at C2 positions and with active methylene groups with 5% and 20%. And we prepared some deuterated starting material and non-deuterated starting material at parallelly. So the KE was observed at 1.55. In the combined experiments, the KE was 1.17. So from the data, we concluded that non-deuterated indolyl more reacted with deuterated indolyl. So after having the control experiments and earlier literature, we proposed that following mechanism. So initially, the rhodium superstar forms the activated rhodium complex from the oxidant. After inhalation of indolyle, it forms the activated rhodium complex A. So this annihilated 5-membered Rhoda cycle migratory insertion of alkanes, it forms the intermediate C with the coordination of hydroxy group. After reductive elimination, it gives the annihilating partner, and the concomitant lactonization, it gives the product 3A. So here the conclusion. In conclusion, we have demonstrated that rhodium catalyzed CH and CO annihilation of indolyle oxopropionitrile with hydroxypropionate to accomplish the a rapid acyclic tetracyclic couples. The reaction was resoselective and stereoselective, perhaps born from the rhodium coordination. This operation is simple protocol, features a broad substrate scope with wide functional group tolerance. So necessary control experiments and labeling experiments were conducted to get the insight into the mechanism. So, and now I'm shifted to the recent work that is published in JOC. So this is iron oxime ethers. So this is well-known feedstock to synthesize the 4-functionalide isoxazoles. So these are some earlier reports, that is alkylation and alkylation and halogenation and sulfonylation and alkylation and carbonyl elimination. So from this collective data over the past reports, there is no reports on CH annulations. So by the interest of our research on CH annulation, we reported that palladium catalyzed CH annulations. That is, so this is highly triple cyclization selective CH annulations. Here both CH are present, but in our strategy, only one CH annulation only happens. So this is the advantage of our strategy. That is selective CH annulation and dual resoselectivity with respect to the 2 pi partners. And so we are optimization studies. After an extensive studies, we concluded that so palladium 10 mole% and zinc acetate 2 equivalents and potassium carbonate 1 equivalent TBAP and DCE at 80 degrees is the finest conditions to deliver the product with 78% of yield. And after having the optimization conditions, so we test our product, our generality of the method with different substrates like different chains, phenyl and methyl and N-propyl, isopropyl, and some rings, 5-member ring and 6-member ring and 7-member ring and 8-member ring, and different fused systems. From these systems, we concluded that so steric index does not affect on our protocol. And next we shifted to the test the substrate scope of the iron oxime ethers with the different positions at irrespective positions. So there are mono substitutions and di substitutions and tri substitution and heterocyclic couples. So all are well tolerated in this protocol. This is our generality of the transformations. Next, we shifted to the control experiment to know the mechanism of the our protocol. So initially, at the same time, we conducted the reaction with diphenylacetylene and propoxylic alcohol without having activated group and activated phenyl propylate. So from these results, we concluded that so there is no annihilated product was formed at diphenylacetylene and propoxylic alcohol. Some complex mixture was observed with phenyl propylate. From this data, the annihilating partner must have activated with O coordination. So at the same time, iron oxime ethers with different coordinating groups. So successfully, methyl group is most give a more yield than comparing with hydroxy and benzyl group. And we also tested our protocol with hydrogens, but unfortunately, this is failed with our desired transformations. And yellow iron oxime ether at standard conditions, it gives the isoxazoles. So isoxazole treated with our alkane partner, so there is no annihilated product was observed. And shifted to the deuterated studies. So at standard conditions with excess amount of deuterated solvents, the deuteration happens at C4 position only. So C4 position only. There is no deuteration happens at any aryl rings, which indicates that the CH activation or CH annihilations happens after the annihilation of pi partner. And we also, some parallel experiments we conducted with the deuterated and non-deuterated compound. So this is non-deuterated starting material, this is deuterated substrates. We carried out at the same time interval, so that the KH by KD was 1.83, which indicates that non-deuterated compound more reacted than deuterated substrate. And we carried out the reaction in a single pot. Here KH by KV value was 1.94. So which indicates that CH activation is rate determining step. After knowing the control experiments and earlier literatures, we reported that the mechanism, initially the palladium trans hydroxy palladations, it forms the oxonium compound. Then it has two paths to react with the anilating partner. Migratory insertion of alkanes, it gives the intermediate C. Then after the reactive elimination, it forms the anilating partner, then gives the product 3IA. So in conclusion, here we reported that, we have demonstrated that palladium catalyzed oxopalladation of iron oxum ethers and triggered concomitant regisative CH annulations to constitute the straightforward access to naphtha oxazoles. The protocol features triple cyclizations and 3 rings in single operation, and dual regiselectivity with respect to the 2 coupling partners. And the key of double annulation, which was electronic bias axial loops, and the necessary control experiments and the KE studies was carried out to understand the reaction mechanism. And thank you to the acknowledgement. Thank you to the CSIR for labbing facility, and CSIR and IICT and UGC for the granting the fellowship. Thank you all.
Range, right? What's yields of your product when you do the substrate score? Yeah. Mostly it's between 40 to 60, most of the cases, right?
First strategy or second one? First method or second one?
Both the cases, yield is not, this is still catalytic reaction, so we expect that.
So, because of we are using transition metals, sir, so there is some amount of side products or some unwanted products may be observed. So that's why the percentage of yield decreases when we are using transition.
TLC observe those products also, right?
We don't have, like we are unable to isolate the byproducts. What the byproducts we are observed on the TLC?
You are running the TLC, are you observing those parts?
No. I think maybe decomposing like happens with the coordination with the metal.
Those compounds are decomposing.
That is not room temperature reaction, that is 80 degrees Celsius.
In TLC?
In TLC also?
Observing any other
Yes.
byproducts?
Yes.
Why? Because most of the compounds are aromatic. No?
Yes.
It should be observed in UV.
Yes.
But you are telling that there are no compounds observed.
What about I'm telling about byproducts only, sir. So the metal coordination is directing group. All the directing group may react with the anilating partner or something else which happens. So that's why yield of the percentage. Not only here, so most of the transition metal catalyzed reactions giving less yield than comparing with
Why do you think
simple
you
acids.
need 2 equivalents of copper acetate? Have you optimized that?
Yes, sir. So when we are using less amount of copper acetate like 1.5 equivalent or 1 equivalents, we are optimized that. So in that case, the percentage of yield decreasing happens. The formation of yield decreasing happens. So that's why we are optimized at 2 equivalent.
Show me the mechanism.
This is the mechanism. Initially, the rhodium forms rhodium oxygen. So the activated rhodium coordinated with the by the indolation of indolent oxygen. So this is the turning point of our strategy when compared with the previous strategies. So in all the strategies, so the C coordination happens, but in our strategy, C rhodium coordination happens. That is the difference between VR reported and others reported. That is the advantage of this work. This is published in GITAM. From the audience? Okay, thank you all.